Hello everyone, so this is an example on first order differential equations. I'm not going to take you through a proof of this, you can look that up somewhere else, okay? But I'm going to give you an example of how to proceed with a first order differential equation. Now assume it's not a simple type like separating the variables, you want to make sure it looks like this. So dy dx plus py equals q. Now p and q are functions of x. They can actually be numerical values only, but they're generally functions of x. And you've got dy dx there. It's critical that it's of this form before you proceed. And the method is you need what's called an integrating factor. The integrating factor, I call it IF for short, is found by working out this. E to the integral of p dx. Remember, p is a function of x. You need to integrate that, and then e to the power that gives you an integrating factor. Next step, you multiply both sides of the original equation by the integrating factor. That is this one here. When I say original, when it's in this form, I mean, okay? Then what you'll have is this result here, that the derivative of the integrating factor multiplied by y will give you the integrating factor multiplied by the right-hand side of q. That will become clearer in the example I give you. And then if you've got the derivative equals something, to undo the derivative, you need to integrate, because integration is the reverse process of differentiation. So integrate to get if times y, the integrated factor times y, equals the integral of the right-hand side. Okay, I'm just going to allow you to get a screenshot of that if you wanted to, and then proceed with the example. So here we go. So solve this differential equation. Dy dx minus 4y equals e to the x. It's of that form, so you've got dy dx minus 4y equals e to the power of x. Remember I said that the functions p or q could be numbers, and in this case p is just a number, -4. First thing is find that, the integrating factor. It's e to the integral of p dx. Remember, p is the value that you multiply y by, and that is going to be e to the -4 dx. So just going back to this, so that says dy dx plus py, so if it's negative, that is going to play an important part in the integrating factor. Integral of -4 with respect to x is -4x. So that's just for the e to the -4x, like that. And then the step is you multiply both sides of this equation by e to the -4x. And then you go ahead and solve it. So multiplying both sides, you'll get that times e to the -4x, that times e to the -4x, and that times e to the -4x. Okay? Of course, what you can do is just simplify this little bit here. This little bit will just be e to the power of -3x. And here's just a reminder of what you should be getting. Okay? It should be the case that the derivative of the integrating factor multiplied by y is equal to the integrating factor multiplied by q. I'm just going to check that with you now, and this will hopefully show you why this whole process is working. So I'm just going to write that down by here while I've got some space. D dx of the integrating factor, which was e to the -4x, multiplied by y. Okay. Let's work out what that is. Okay. So when you differentiate this, you've got a product of two terms. So you've got this multiplied by this. Using the product rule differentiation, remember that's v du dx plus u dv dx. I'm just going to highlight that there, the product rule differentiation, whereas we'll let that be u and let that be v. So I need to do v multiplied by du dx, so the derivative of e to the -4x is -4 e to the -4x. So that's my dv dx. So that's my du dx multiplied by v. I'm going to get y multiplied by that. Added to u dv dx, so u is e to the -4x, and when you differentiate y with respect to x, got to do it implicitly, that's dy dx. Okay? So I've just shown you that the derivative of this is equal to that. And notice that that is the same as this. Okay? That's why this whole process is working. Okay? Hence this line here, that the derivative of the integrating factor multiplied by y will give you this on the left-hand side. On the right-hand side, of course, you've got the integrating factor multiplied by q. So the next step is you just integrate both sides to get this. So you're left with the integrating factor multiplied by y. So this here, because we're undoing the derivative, this is equal to the integral of the right-hand side. Okay? And this is the critical step that you want to get down to. The whole point of the integrating factor is, once you've done the multiplication, you'll end up with this result here. You can memorise it if you wish, just memorise it as whatever your integrating factor is, multiplied by y, that's going to give you the integral of the right-hand side integrating factor multiplied by q. And then this is all we need to solve. So that's here on the next page. I'm looking up here. So the right hand side just stays as it is, e to the negative 4x multiplied by y, and then integrate this. That's going to be negative a third e to the negative 3x. And then don't forget the plus c, the constant of integration. Sometimes you're asked to write the answer in the form y equals something. So if you do that, multiply both sides by e to the 4x. And so this bit here will become negative a third e to the x, and then plus c e to the 4x. And this is what we call a general solution. A general solution is a solution to an equation, a differential equation, when you've still got a constant in it. A particular solution is if you're given a couple of boundary conditions, for example, when x equals this number, y equals this number, then you can substitute into work out c. That would be a particular solution, but this is just a general solution. Right, I'm hoping that found you useful. And remember, you can always watch it again if you need to pick up on something you just missed out first time. Thanks. See you again.